Okay, Mario once again with MIA Microflight. Today is Thursday, January the 22nd, 2026, and in this video you're viewing once again the RC era C189 without the body. I had to take out the body in order to fix this servo on the right hand side. That the little motor in the servo was bad, so I replaced the motor and it's been working just fine. I've been also playing around with the calibration of the transmitter just to get the pitch on the blades to a level where it's not too abrupt, but it's not too low where it just spins and it doesn't lift. For anybody that has done that, you probably are aware that you got to be very careful on those settings because you are programming the flight controller. I've noticed some people, they get the helicopter up and hovering, and then they start tweaking the controls. If you tweak the pitch on the blades too much and the helicopter has enough power, enough throttle, that thing is going to take off vertically, as it did in one instance that while I was tweaking it indoor. Luckily I was indoor, that it hit the ceiling, and I was able to recover it that way. A little bit of damage on the blades, but nothing major. But just be aware of that when you do that. I would recommend that if you're going to tweak this, you find that sweet spot by calibrating the radio, just using the trimmers as you're flying this. Don't go into the secret programming mode. Just do it via the trimming in real time, and then find out how many clicks it takes, to get that just to a stable hover. Remember the number of clicks forward or on the aileron in the elevator, pitch and roll, and then you can transfer those when you're programming this without the helicopter being hovering. When it's on a table and you're retaining the helicopter, I would recommend that you retain it. The way I program is I hold the helicopter and then I turn it on and work with my other hand. But it's better just to clamp the helicopter and then just transfer those settings that I just mentioned onto the flight controller via the programming mode, which is when you have to hold the left the left trimmer. Let me grab my transmitter. So that when you're programming this, you hit this down like that, and the light blinks. That's in programming mode, and then you just tweak your settings on the pitch and roll here via these trimmers right here. Remember I said if you tweak this in real time without the programming feature. Without going into programming, just remember how many clicks you click, to get it as stable as possible, and then transfer those in the programming. Just click that number via these trimmers. Once you're done with that, turn this off, or that's going to it's going to record that in the flight controller memory. That's on the pitch and roll. On the pitch for the blades, the collective pitch, same thing, down, programming mode, and then more to the, I believe more is to the left and less is to the right. It should be more to the right, and less to the left. -1, -2, -3, -3 to the left, and +1, +2, +3 to the right. But I think this is opposite of that, if I'm remembering this correctly. Double check on that. If you're in case you're wondering, you're not sure. I'm not sure at this point, but I think it's I think it's to the left is positive, more positive pitch on the blades, and to the left is less pitch. So you just want to do this in one click. Don't go crazy doing this in 2-3 clicks at a time, because if you put too much pitch on this thing and you go and fly this, you may have enough pitch and power there to take this way up high, and then the only way to bring that down is through the kill switch, which you have to hold it for 2 seconds. So just be aware of those things. you know, that's those are the pros and cons of having a flight controller that it's using almost you know, artificial intelligence to do the flying for you. Basically, that's what it is. You know, all these gyros and sensors that is used to calibrate you know, the pitch, roll, and yaw. If one of those things is not set right, or if you have an issue with mechanical issue with one of the servos, you know, it doesn't serve you any good to have a properly set up flight controller, because that mechanical control is not going to work, and this is going to it's just not going to do it's not that beeping is my lithium polymer battery charger that I'm charging. So just be aware of that, those details. I know some videos they make it look so easy, and maybe for the author of those videos it is easy, but I would caution, because I have gone through that sequence, and it's you know, you just gotta, nobody's mentioning that you have to approach these things with caution, because you are programming the flight controller, and if you do it in real time while this thing is hovering, chances are that if you put too much pitch here, that thing is going to fly away from you. So just be aware of that. Anyway, what this video was, what I really wanted to get in this video is the 3D printed blades that I did for this helicopter, because I ended up breaking the tail blade, and not realizing that there's a spare in the box. I ended up making this little blade out of a just you know, one of those toy quadcopter propellers. Just sized this according to the actual blade, and then I trimmed it. Make sure that you balance this, because any unbalance on these high speed motors, you know, it's going to show up. It's going to vibrate, and you don't want that thing to vibrate, and sometimes it goes out of control, you know, through vibration. So make sure that is balanced before you install it on the motor. I have, however, done my own 3D printed blades, because I was figuring that also that the rotor head, if you tighten these screws too much, the rotor is going to be a little quirky. It's going to be it's going to you know, it's going to want to do this, you know, really abrupt, you know, on the controls. It's not fluid. It's not smooth, you know, as it should be. And the only way to get this smooth is by introducing damping in either the blade grips or the rotor head. There's no way to introduce damping in this rotor head the way it's designed. So what I did instead was I designed the blades, these 3D printed blades that you see here. I also did the tail blades. Also, these have to be molded with a little heat. Put that curvature there so that it has that airfoil. I've shown that in some other videos. You know, you can check out all that stuff I've shown previously, so I'm not going to go too much into detail as far as the molding of this. But as far as these blades, these do have an airfoil, and this is my second take. You can see the airfoil there. My first take was I made these at 1.5 millimeters in height at the highest point of that airfoil. That is a Clark Y airfoil on these blades. I don't know if these have these are not symmetrical. These are also flat bottom. Clark Y airfoil, you know, that is typically used on fixed pitch helicopters. Even though this is collective, that's fine here, because I believe this will fly inverted, but it's not a full symmetrical blade, so it may have just a little curvature on the bottom. You know, it's kind of hard to do that on a 3D printer without, you know, using supports, and so I didn't want to do that. I just made him straight Clark Y airfoil on that on the profile, and this is like I said, this is my second take at a 2 millimeter height. This was at 1.5, and it was just too flexible. These are, I would say that they're a very close approximation to the tensile strength. No, well, not tensile strength, but to the stiffness of the blade. You can see, you know, they flex at about the same point. See, these are ABS molded blades. This is a PLA molded, and I think that the 2 millimeter height, which is about what this is, it's pretty close. I also made it with a larger mounting hole, and that is so that I can introduce damping in the blade. Also, the thickness of this section right here, this has a little higher thickness because it fits almost very precise between the inside that blade grip. This one actually has a little bit of less height, so that it has some way to flex up and down. And the way I'm doing this is I'm introducing an O-ring inside this, proper size O-ring inside this this large inside diameter hole, so that provides the damping on the blade. So it's going to be, if this works out correctly, as I'm imagining this is going to work. Also experience, I've done similar blades in the past, so I'm kind of using my experience more than anything. I do know that it's going to work at this point with some reassurance. So let me put it that way. So that O-ring is going to provide that damping. It's going to be a lot smoother in the control of the rotor head, instead of having these blades right here, which fit perfectly, almost like a glove fit in the blade grip, and has no. The only damping is on the flexing of the blade itself. Whether this blade not only has that flex on the material of the blade, but it also has right there where it should be. Damping should be introduced right at the pivot point of the pivot, means this way of the bolt right there. In full scale helicopters, you have sometimes you introduce a little more complexity there, not only to have that type of damping, but also twisting, and also sideways damping on the blades, so everything is very, very smooth. The purpose of damping is just to get that rotor head as smooth as possible, rotating, and especially when it's under control. Best way I can describe that. And so these are my 3D printed blades. I printed these at 0.1 millimeters in height. I typically print things in 0.2, 0.3. 0.3 I print larger stuff. 0.2 I print something that requires a little more finesse. But these I printed at 0.1 because the 0.15 is that other blade that I was showing here. That's a 0.15, and you can see how the layering was it was doing some funky things on my machine for some reason. And so I printed these at just a little bit slower than regular speed. I think I printed this at 75%, the normal speed, which is 100, at what is it, 100 millimeters per second, 100 millimeters per second. No, this was printed a lot slower than that. But anyway, this is the it came out really, really nice. I mean, there's one in particular blade. Some of these develop little boogers on the from the 3D printer. I have to recalibrate my 3D printer. But one of them, I think it's this one, printed so beautiful. Yeah, this is the one that printed so clean at 0.1 millimeter thickness. So it's almost like an injection molded blade. So I'm printing a second set. Just to have them just in case. So I'm going to be testing these. I'm going to color them so they have a nice, a nice visible pattern on the blades as the rotor is rotating. And I'm going to be testing them in the next video. So stay tuned for that video. I'll do a short just to keep things short and sweet, but I'll probably also do a long video. Mario once again. Stay tuned for more. Thanks for watching.